In this video, I'm going to walk through some of the questions on the word worksheet. The three dash let's see here 3-1-1 word worksheet, or 3-1-2 actually word worksheet. The sampling distribution and central limit theorem. And so I'm going to go ahead and share my screen with you. And so what you see right now is I uploaded this so that way it's all in Excel, and I'll show you. I'll put it under the Unit 3, um, right next to where you would normally download this. So Unit 3, uh, um, I'll show you where I'll put it. Let's see here. So you go here to Unit 3, and I'm going to put it right here under Unit 3 worksheets. I'm going to put 3-1-1 Word worksheet in Excel, and I'll put a link for it right here so you can download it. Okay, so what we have right here is the GPA, midpoint, so on and so forth for the very first question. And the question specifically says, it wants you to calculate all the means for freshman, sophomore, junior, senior, and for total. And so for question 1, it says, please calculate the average mean for each one. And so I'm going to show you guys how to do that really quickly. The first thing that we got to do, remember, in order to calculate the mean of group data, you multiply the relative frequency by the value, and you add those together to get the means. And I show you guys how to do that longhand on the word worksheet, but I'm going to show you how to do it in Excel. So we're going to do equals 7 divided by 239. And so 239 right there, and I'm going to make it so that the 8 does not move. So I'm going to drag it down. So now this is 14 divided by 239, 86 divided by 239, 132 divided by 239. And then I'm going to drag this down, and because I only made it so that the 8 didn't move, now each one of these, so this is going to be 5 divided by 229, so on and so forth, going all the way down. So with just that, we calculated the relative frequency of all of them. Next thing that we're going to do is we are going to calculate the mean. In order to calculate the mean, you do relative frequency multiplied by each midpoint, and then you have to add all of the relative frequencies multiplied by each midpoint. Okay, so that's what we're going to do. So equals the midpoint multiplied by the relative frequency of freshmen, so the midpoint of 0.5 multiplied by the relative frequency, and then I'm going to drag that down. But in order to do that, I still need to make it so that C4, we don't want the C to move. So I'm going to put a dollar sign in front of the C because I'm about to drag it over. So let's do that one more time. So we'll put a dollar sign in front of C and drag it down. And then we're going to drag it over. So now, in just a few moves, we got all of the information that we need to calculate the mean. So equals sum, because we've got to add these all together. And then you can drag it over. And so we've got the means as well. So that's how we do it, much quicker than what I showed you guys how to do it in the Word worksheet. You can do it longhand. It's certainly accurate, but this is just much quicker. Next thing that I want you to pay attention to, we go down to question 8. And with question 8, there's a random selection of 45 freshmen. It has a mean GPA of 2.835 and a sample standard deviation. Here, let's merge. Of what's that called? Of 0.734. And so what we do here, everything that's not highlighted right here, is what you need in order to calculate everything that is highlighted. So everything that's highlighted is a calculation. Everything that's not highlighted is not a calculation. So we're going to put the sample mean. First of all, it says the 45 freshmen. So it's a sample of 45 freshmen that has a mean GPA of 2.835. Okay, and then the population mean. Well, we've got that right here. So we're just going to Control C and then we're going to come up here and do paste values. So we've got the population mean, and then the standard deviation of 0.734, and then the sample size. Sample size is 45. Okay, now, like I said, all of these are calculations: sampling error, standard error, sample z-score, probability below, single observation z-score, probability below that. And so, and I have the way that it's calculated over here on the right-hand side. Sampling error. In order to get the sampling error, or this is also known as the difference score or difference value, what we're going to do is do equals the sample mean minus the population mean. So we've got the sampling error, and then with the standard error, it's going to be the standard deviation divided by the square root of the sample size. So equals standard deviation divided by square root of the sample size. Okay. Then we have a sample z-score. Okay, a sample z-score is, remember, we're dealing with a sample, and you know, a place where you can find all of this information, it's all listed out on your Unit 3 Excel sheet. It's all right here. So you've got the z-score right here. You've got the single sample or the single observation z-score. You've got sampling error. You've got the error score, difference score. So it's all right here, just with a whole lot more information, right? And so I just want you guys to see it's definitely here. Just we're putting it in something that's much more compact. Okay, so sample z-score. We've got the sample z-score is going to be equals sampling error divided by the standard error. Okay, so we've got the sample z-score right there. And then the probability below that, and so the probability below is going to be equals norm.s.dist. And we're going to put the z-score and type in true. And if we wanted to do the probability above, you would do 1 minus this. But we're not doing the probability above right now. I'm trying to keep it really simple with just the probability below. I want you to do the probability below over and over and over again for you guys to remember, hey, this gives you the probability of it being below. Okay. And then the probability, or sorry, the single observation z-score. So it's going to be the sampling error divided by the standard deviation. So, or the difference score or the error score. So equals this. So if this was just a single observation instead of a sample of 45, you would do 45. You would do the difference score divided by the standard deviation. Okay, and then the probability below that is equals norm.s.dist, and then you put the z-score and true. Now the really cool thing about this, and I hesitate to even show this to you, well, but before I do this, I just want you guys to see, hey, you've got this content right here, these values, okay? And you have these values, and when you reference back to them, notice I didn't type any values in. All that I did was, hey, I'm using these two values to calculate this, so equals this minus this, and I clicked on it. Equals standard deviation divided by the square root of the sample size. Equals sampling error, and I clicked on sampling error, divided by standard error, because I just calculated those two. Then equals norm.s.dist. Then I clicked on the z-score and I typed in true. And so all of these are just clicking so on and so forth on it and clicking references. So this right here is question number 8. And then I also have it set up the same way. And so I've got the sample mean, population mean, sampling error, standard deviation, sample size. And if we wanted to, let's see here, we can highlight these to be like, hey, these are the ones that we're calculating. So we're calculating these. So it's the exact same thing, but this is for calculating for the probability of a sample. This is for calculating for the probability of an individual observation. So I want you to see that calculating a z-score and the probabilities associated with a z-score is extremely similar for both. It's just this one over here, instead of having a sample size of 45, you have a sample size of 1. And so because you have a sample size of 1, it makes it so that you divide this down here by the standard deviation instead of over here, you're dividing it by the standard error. And then also in class, we talked about, how these standard error, and there's another video that goes over this, and so I'm not going to spend much time on this, but you've got the mean plus or minus the standard error, and then the mean plus or minus the standard deviation, and standard deviation is much more spread out. So a population distribution is much more spread out than a sampling distribution of the sample means. So this right here, though, what I want you to see is because we have this, it doesn't change, okay? You are going to do this thing over and over and over again, and you can literally just copy this, Control C, Control, whoops, and Control C, Control V, and you can delete all this if you want, and start all over. There's another option that you have. You can just delete this, okay? And when you delete this, now you can look at it and be like, okay, what's the sample mean? You look at it, okay, sample mean is 3. Population mean, what does the population mean? Population mean, ooh, that's right up here. Control C, come down here, paste the value, okay? And then we've got the standard deviation. What's the standard deviation? Okay, it's 0.73. And then what's the sample size? N, okay, 62. Because I had these 4 pieces of information, because these are the 4 pieces of information I need to gather. Once I get those 4 pieces of information, everything else can just automatically calculate. The big thing that I want you to take away from this, get these 4 pieces of information, know these formulas, and once you know these formulas, you can do everything else. So it's like, get these 4, then you can do everything else. And you can copy and paste it again. And you're like, Control C, and put it right here. Okay, delete these, update all the information to match the new question, and do it again and again and again and again and again. And this is also another reason why I don't necessarily want you to have something like this on the exam, because I want you to know how to do it by hand, because you guys would just go in with this and you'd be like, hey, I already have it all set up, ready to go, and you just put in the 4 pieces of information, it gives you all the answers. Instead, for the exam, have this written down and then have these formulas written down next to it, and then you can put it into Excel and calculate it really easily. And so I'm going to put it, what's that called? I'm going to put this into Canvas for you, so that way you can do all this work yourself if you want to in this fashion. And I'm deleting all of this as well because I want you to do it by hand yourself. I don't want you to just use my work. And then once you do that, you're going to be able to answer all the questions. Another thing that's really important, it says a random selection of 10 seniors has a mean GPA of 3.0. When you have a random selection of 10 seniors, we don't know how this data is distributed, but seniors, actually I do know. It's very positively skewed. And so yeah, just be aware of that. The data is extremely skewed. So you've got to have a sample of at least 30 in order to get insight from your z-scores. You can still calculate a z-score. It's just you can't calculate a probability from the z-score that's accurate unless it's 30 or more. So be aware of that. So I'm going to save this. It's called Excel Works Standard Error Z Values, and I'm going to upload it for you guys to work on that.